Okay, let us start our discussion on oblique asymptotes. How to find out the oblique asymptote if curve of the curve y is equal to mx plus c, it is in the form of what happens whenever there is a curve is given something, it is in the form of f of x y is equal to 0, f of x y. Its curve behavior is determined by its highest degree coefficient terms. It means that with an example we can confirm. No doubt we can take a very simple logic. Suppose f of xy is given by the curve is given by fn of xy plus fn n minus xy, means it contains the first degree terms with n degree terms, second n minus 1 degree terms, like that. But as we increase extends to infinity, the curve behavior is only sufficient to we neglect the lowest degree terms and only take the part of mn fn of xy and solve it, finding the y value. Is it same as directly putting the x value in directly in that equation f of xy and getting y? With an example I can clarify you. Take for example, we have a consider equation curve x square minus xy minus 2y square plus x plus y is equal to 0. This is the curve. See, I want to curve behavior whenever x tends to infinity. Whenever x is large, what is the value of y here? We need to find y, how the y behaves. Y behaves, okay? How to find out that? For that we take highest degree terms. Is it that then you can see you can put x value highest value in this equation, and simply, for example, if I say something x is equal to some value, it is in high school mathematics like that, finding the y value in a similar fashion. If I x is very large, what is the value of y here? By only is taking the highest degree coefficient, that is x square minus xy minus 2y square, is solve it. X value is what? Very large. What is the value of y? That is sufficient. Take for example, if you take x square highest degree terms here, x square minus xy minus 2y square is equal to 0. This is the highest degree term. In this case, if you make a factorization, it becomes x minus 2y into x plus y is equal to 0. Then you can get the y value is x by 2 or y is equal to minus x. These value gives the curve behavior at infinity. But take with an example you can clarify. As I told you, verification, if you take x is equal to very large, what we can get? X is equal to 1000, we can get it. Whatever by this 1000 means, that is we can get y is equal to 500, because x y is equal to x by 2 means 1000 by 2, that is equal to 500, or y is equal to minus 100. You can completely use. But whenever we directly substitution x is equal to 1000 in this equation, in this equation, we can get what value? We can get by directly x is equal to 1000 value, you can get these values. What value? Complete equation, if you use it, you can get almost y is equal to 500.17 or y is equal to minus 999.67. Means the both are same. Now by that you can confirm whenever x tends to infinity, the curve behavior is dominated by highest degree terms. This is the conclusion. The behavior of the curve at infinity is determined by the highest degree equation. After this conclusion, we can go to the second highest degree terms. Why? See, but it is only gives part of the y part of the curve. See, y is equal to mx plus, you can get it. Okay. Now, the original equation, we know that original equation x square minus xy minus 2y square plus x plus y. And factor out it, we can get x minus 2y into x plus y plus x plus y. You can take x plus y as a common, and then we can get what we can get x what we can get x plus y into x minus y plus 2 1. If you take common factor, we know that this x plus y is not equal to 0, because what we get y is equal to x by 2 by taking that, since x is 10 to infinity, that is x plus y is not equal to 0, there is only possibility that x minus 2y plus 1 is equal to 0. Therefore, I can say that we can finally, after simplification, x minus 2y is equal to minus 1 and 2y is equal to x plus 1. Therefore, y is equal to x by 2 plus 1 by 2. Means whatever the behavior y, finding the y value only by using highest degree terms, and by taking second part also, you can get the second part of the y value. Try to understand. The second part y value also we are going to find out. Therefore, whatever this core concept is, the h degree term determine the direction, the still shift. See here, the second highest degree terms also we are going to find out. The curve behavior, the part of the, but whatever this value, what we have did here, you taking the highest degree terms and solving the x y value in the form of x y is equal to mx, you can get it, and by using that we can we are going to solve the uh, entire equation by taking the original equation, and because we consider the second part also, and we are going to directly finding the, whenever x is very large, this is the case as I told you. But by directly another method, second method, the same asymptote is obtained by using standard method also. What is that method? Let us assume, you are going to assume this y is equal to mx plus c is the asymptote. For that, we are going to substitute in the equation and compare the highest degree terms. See, after substitution from the highest degree terms, what happens? You can get the same curve. I am telling you, whatever this curve only, I am telling about this curve only. By, I can say that y is equal to mx plus c, and in this equation, or we can take um, by substitution that thing, and y is equal to mx plus c, and solving that, the same equation. Okay, after assume and substitution equation and comparing the highest degree terms, what we can get? We can get the equation from the highest degree terms. You can get the equation like 1 minus m square, 1 minus m minus 2m square is equal to 0. After factorize out, you can get m value to m minus 1 into m plus 1 is equal to 0, m is equal to 1 by 2, m is equal to minus 1. Same thing, you can get it. After, how to find out? Take the m is equal to 1 by 2 and substitute in the original equation, simplifying, and gives, I can say that like that. Once if you know the, or can substitute, that is what you can say that the highest degree terms, and after in the equation also we can get same thing. Okay, this is what, how can we find out the asymptote? Asymptote means what we can say, the only thing is the same final asymptote we can get. What is the value of x? Is tends to infinity. How x tends to infinity means x is very large, not only for single. X tends to infinity means x is taking larger and larger values. It may be 1000, 1 lakh, 1 crore value, like that. It may be higher value. In that case, y is acting as a straight line. That's, if I get like that, it is in the linear form, but it acts as a asymptote. This is how we can conclude about that. But we can, as I told you, different methods. One simple method, directly we can take highest degree terms and solve for y is equal to something. We can put it that by using that also we can find out the second, because only we are going to part of the y value, but still some portion is there of that y value that is taken by the second highest degree term by considering the second highest degree terms that I told you. Because here, here the original equation is there, original equation this one. After taking this one, by we know that already x plus y is not equal to 0, by that information is used here, and second part we can solve it, and we can get final simplification, and y is equal to, but like that we can use that information and finding the second part also. This is how we can uh, find out the things. Okay.